Good morning, sixth grade. This video is for Tuesday, May 5th, Taco Tuesday, Cinco de Mayo. I hope you guys have tacos for dinner tonight. So I'm gonna share my screen so you guys, I can go over what your assignment is for today. Remember to go into the folders, scroll and click the schedule. Make sure you guys look at the schedule. I already had it open, so you're going to watch this instructional video. You're going to watch another video that's on Pearson, the patterns of circulation in the ocean, and then you're going to do the interactivity on Pearson, which is oceanic circulation, and we have Zoom at 11. And I actually liked doing the assignment with the students who came on Zoom today. We did it together. So if you guys want to do your assignment with me tomorrow, please feel free to come join us on Zoom. I'm going to hit view student status. That's not what I want. Preview the assignment. Okay, so I'm just going to preview this for you guys really quick. Okay, so it's 6 slides, as you see down here, 1 of 6. Make sure you read everything. Make sure you play all the videos. Make sure you go through everything and you click everything and you read everything that's on these little things, because this is all of the information. And by the time you get to this part, which are the questions, then you need to have known, so you guys know the information. The information that you guys need to know for this stuff is in this assignment. So there was those 2 questions, 2 more questions, and then a 5th question. So all you guys have are 5 little questions after you guys read the slides. So I'm going to get back out of that. I'm going to stop sharing so I can go back to my PowerPoint. My PowerPoint today is a different one from yesterday. I'm going to upload it to the folder for you guys after I upload this video. Hopefully this video actually uploads to YouTube. My video was fighting with me yesterday. Didn't want to upload to YouTube correctly. So you guys are going to make sure you guys read this and go over it. Like, I would suggest, even though I have it on the screen, like, you guys should still look at it. Okay, so the influence of ocean currents. It all begins with the sun. Okay, ocean currents. So ocean currents are mass movement or flow of ocean water, river within the ocean, and there's 2 types, surface and deep. So there's surface currents and deep currents. Ocean currents. So surface currents are the upper 400 meters of the ocean, which is only about 10% of the ocean. And then the deep currents are thermal and salinity currents, and that's about 90% of the ocean. This map right here looks similar to the one that's in your assignment. Okay, I'm going to click this link. I'm not even gonna lie to you, I don't know what's on it. So surface currents, they're horizontal stream-like movements of horizontal stream-like movements of water that occur at or near the surface of the ocean. They can reach depths of several hundred meters, and examples are gyres. I don't know how to say that word. Just because I'm a teacher doesn't mean I know how to read or sound stuff out. Oh, my flash is not. Oh, this is showing us the currents. Okay, so that's from the link. So you guys should really look at the, I'm gonna stop sharing really quick and go back to it because I know sometimes you guys can't see stuff. So this is the link that I clicked, and it shows the surface currents of the ocean are primarily driven by the wind examine the relationship between global wind directions and the direction of the surface currents. Notice the currents flowing towards the equator are generally cool, and the currents flowing away from the equator are warm. So that means it's warmer by the equator. So if it's flowing away from the equator, the currents are going to be warm. And if it's flowing towards the equator because the other areas are cooler, it's going to be cooler. So these are just the currents by itself, but then when I put my cursor on top, it's showing the global winds as well. Okay, going back to the PowerPoint. Surface currents are controlled by three factors. They're controlled by the global winds, the Coriolis effect, and the continental deflections. So global winds, so with surface currents, global winds are cause surface currents to flow in the direction of the global wind, for example, the jet stream, and the Coriolis effect, the apparent curving of moving objects due to the Earth's rotation. So the Coriolis effect is caused by the Earth's rotation, how the Earth moves, which causes surface currents. And this link, let me just make sure that you guys do see this. Okay, this one you guys should, oh no, it's just showing the different, it's showing the movement of the paths. So a plane flying from Anchorage, Alaska, directly towards Miami, Florida, would miss its target due to the Coriolis effect. The target location where the plane was headed when it took off has moved with the Earth's rotation. So the plane would end up right to the right of its original target. So the plane would have ended up in the ocean if it went directly, meaning if it took a straight path. So normally when planes fly, they don't take a straight path. They fly in different angles. A plane flying from Tierra del Fuego, Argentina, directly towards Rio de Janeiro, Brazil, would miss its target due to the Coriolis effect. The target location where the plane was headed when it took off has moved with Earth's rotation, so the plane would end up to the left of its original target. In reality, pilots take the Coriolis effect into account so they do not miss their targets. So being a pilot, not only that you've got hundreds of people's lives in your hands and you're powering like this heavy machinery, you need to know a lot about navigating through the atmosphere and the winds and how they affect the direction and the path of the plane. So the reason why it goes in a different path is because South America is in the southern hemisphere and North America is in the northern hemisphere. So that's why from Anchorage to Miami, it would veer to the right. And then from Tierra del Fuego, Argentina to Rio de Janeiro, Brazil, it goes to the left. It's because of the difference in the hemispheres, which is actually a true thing because the water in the toilet spins down the toilet differently in South America. Very true. I witnessed it in college. Anyways, moving on. Surface currents continued. So the Coriolis effect. So like I just said, it goes a little differently. So the northern hemisphere goes clockwise. That's why it's going to go, no, that didn't make sense. But the northern hemisphere goes clockwise, and then the southern hemisphere goes counterclockwise. And the continental deflections, the shape of the continents, change the direction of the current flow. Deep currents, so this is the second type of currents. It's a stream-like movement of ocean water far below the surface caused by changes in density, change in temperature, and change in salinity. Salinity means the amount of salt. And then what affects the deep currents? So it's a change in temperature and a change in salinity. So the change in temperature, decreasing the temperature of water increases the density. So the reason why the temperature decreases is because the further down it goes, the deeper in the ocean it goes, the colder the water gets because it's not getting heated from the sun. And the change in salinity increasing the salinity of water increases its density. So water becomes more dense the more salt that there is in it. That's why in the Dead Sea, because it's full of salt, you can actually float in the Dead Sea without sinking. Okay, so currents and climate. Warm water currents, they bring warm water to colder regions. So, for example, how it said the equator brings the currents leaving from the equator bring the warm water to the colder areas, and then cold water currents bring cold water to the warmer regions. So the areas that are further north that are colder or further south that are colder of the equator, when those waters go toward the equator, it brings colder water to that area. And why are ocean currents important? They make the average temperatures of climates more similar. So this is on a large scale. Ocean air holds a lot of water vapor, so there is more rain at the coast. Currents redistribute heat throughout the globe. For example, the Gulf Stream brings warm air to England, making it warmer. And there you have it. That is it. We are done with that PowerPoint. I'm going to upload it now, and hopefully this video uploads to YouTube. If not, it'll definitely be in the folder section. Okay, guys, I'll see you on Zoom. Don't forget that I said that we'll be doing your assignment on Zoom, so I highly suggest you come and join us so you could just get it done and over with. All right, bye, guys.